Thanks. I hope you enjoyed your lunch. I want to move forward as quickly as possible because our dear friend Ray Anderson has a plane to catch, and we want to make sure that you have the full opportunity to connect with him. So if I could have your attention for, again, please. Okay, the story is now legend. The spear in the chest epiphany Ray Anderson experienced when he first read Paul Hawken's The Ecology of Commerce while seeking inspiration for a speech to an interfaith task force on the company's environmental vision. 14 years and a sea change later, Interface Incorporated is nearly halfway to Mission Zero. Mission Zero is the company's promise to eliminate the negative impact it may have on the environment by the year 2020 through the redesign of processes and products, the pioneering of new technologies, and efforts to reduce or eliminate waste and harmful emissions while increasing the use of renewable materials and sources of energy. In effect, the idea of industrial ecology. Anderson's vision and Mission Zero have forever changed the once petroleum-intensive industry of carpet manufacturing. Today, he commands the world's largest producer of commercial floor coverings. Interface has diversified and globalized its business with sales in 110 countries and manufacturing facilities on 4 continents. Ray was the co-chair of the President's Council on Sustainable Development during the Clinton years. After the Rio Summit in 1992, each country that was part of that effort had agreed to establish a council on sustainable development and to come up with a sustainable development plan for the country. And Ray was tapped as the co-chair of that effort. He's been a recipient of the Mitchell Environmental Prize. He has inspired thousands and thousands of people in colleges and universities. I have been fortunate to have worked with his company, to have worked with him as a member of the board of directors of the Natural Step in the United States. And I have to tell you that no one has done a better job of helping to, particularly in higher education, to have people in higher education at very strategic levels understand the necessity of retraining the way we train engineers, economists, and others so that we can create a healthy, just, and sustainable world. When the history books are written about the transition to a sustainable society, there will be this beacon that will be Interface, and Ray Anderson will be at the head of that beacon. So it's with great pleasure I introduce my good friend and mentor, Ray Anderson. Oh, his book, Mid-Course Correction, he's going to sign it later.
Well, good afternoon. Greetings from Atlanta on this World Environment Day. How many knew today? Well, it didn't get around very well, did it? Nice timing, though. Thank you, Tony, for your generous introduction. I'm delighted and, of course, privileged to speak to this group of people at the invitation of my friend and comrade in arms for Earth, Tony Cortese. Peter Wegge, thank you for your generous sponsorship of this event, and thank you for your comments and for all that you do. And thank you all for your commitment to climate protection. It's great to see old friends and make new friends. Tony, if I were introducing myself, I would say simply that I'm a husband, the father of 2 daughters, and the grandfather of 5 terrific grandchildren. And I'm an industrialist. Some would say a radical industrialist. But I can assure you I am as competitive as anybody you know, as profit-minded as anybody you know. I founded my company Interface 35 years ago from absolute scratch, from just an idea to produce carpet tiles in America. Today, Interface is a global company, Tony's already told you, with sales in 110 countries, totaling more than $1 billion last year. To many of you, I would not miss the opportunity to thank you for your business. In 1994, 14 years ago, almost, I set this third child of mine, after my two natural daughters, on the path to sustainability. So my involvement with sustainability is largely in the context of an industrial enterprise, a petro-intensive enterprise for both materials and energy. And I speak to you this afternoon out of that experience, hopefully to help you understand the kinds of real and practical changes that underlie the concept of sustainability. My assignment today, therefore, is to introduce you to my world, perhaps in a way that you've not heard before, to paint a picture in words to describe sustainability in action on the factory floor. I also hope to raise the bar in your minds as to what sustainability demands of us all. But to gain the most from this visit to my world, you must be willing to think analogously of your own world, to find the analogs and the corollaries. I also hope you will gain a sense of the underlying invention, the reinvention of the entire industrial system that is required, and your role in it, if we are to see widespread, truly sustainable production of the products we use in our everyday lives. To be clear, I speak of the industrial system of which we are all a part, and for which you are preparing all of your students. And when I give you my own definition of sustainability at Interface, eventually to operate our petro-intensive company in such a way as to take from the earth only that which is naturally and rapidly renewable, not another fresh drop of oil, and to do no harm to the biosphere, I hope you will not tune me out as an absolute nutcase. So come on into my world. Here we go. Does this sound working okay all around the room? Good. A mechanical engineer is commissioned to design a production line to produce the same product at the same production rate as a production line he designed and built 10 years before. The process requires the pumping of a lot of viscous liquid. This time he designs it to use 93% less horsepower, 1/14 as much. How can this be possible? Well, this time he specifies big pipes and small motors to pump the viscous material rather than small pipes and big motors. He arranges to install the big, short, straight pipes first and then install the production line thereafter, rather than installing the production line first and bending pipes here and there to fit them to the line. He's largely defeated the pump's enemy, friction. He now knows that friction varies inversely with the fifth power of pipe diameter. And every bend in a pipe further increases friction and decreases efficiency, as does pipe length. Doesn't every engineer learn these things in school? Apparently not. This is new thinking. And yes, the entire production line costs less to build than its counterpart built 10 years before, and less to operate. The engineer has practiced whole system optimization. New thinking that has evolved from just 10 years before. Another factory engineer, also thinking in new ways, calls his counterpart at the city in which the factory is located. The conversation goes like this: say, Patrick, the city has that unregulated landfill east of town. Any idea how much methane is coming off it, going straight into the atmosphere? The city engineer replies, no, but I don't think it's much. Well, why don't you check? Okay, I'll get back to you. He checks and he is amazed at how much methane there is and how offensive it is to the nearby African-American neighborhood. 20 circling vultures attest to that. The two engineers begin to collaborate, and a year later, a public-private partnership is solidified. The city commits the $3 million in capital cost to capture and pipe methane 9 miles to the factory. The factory commits $50,000 to adapt 2 boilers, representing about 8% of the factory's total energy usage, to substitute the methane for the present natural gas. The two agree on a price for energy that's 30% less than natural gas per unit of energy. And calculations indicate the landfill will have a life of 40 years, which translates into a revenue stream for the city at present value of some $35 million for a $3 million investment. A further advantage emerges. As methane is drawn off, the entire volume of the landfill is drawn down, increasing its capacity, enough to allow the city to postpone opening its next landfill for an estimated 15 years. This is win-win-win, new and synergistic thinking. To recap who has won, the city reaps a huge financial return on its investment, converting a polluting waste stream into a lucrative revenue stream and postponing the cost of opening a second landfill for years. An offensive public nuisance is eliminated and environmental injustice corrected. The factory reduces its energy cost and increases its use of renewable energy, and the Earth is spared greenhouse gas emissions that contribute 23 times as much as carbon dioxide to global warming. Methane is that powerful as a greenhouse gas, really 60 times as powerful, but it remains in the atmosphere a shorter time than CO2. The factory, therefore, receives the benefit of a greenhouse gas offset of 23 times 8%, or 184% of its total energy usage, and now can declare its operations climate neutral. For a further modest investment in verified offsets, the factory can neutralize its entire supply chain's contribution to global warming and declare its products now to be climate neutral for their full life cycle, independent third-party certified. The marketing arm of the factory realizes the market appeal of climate neutral and dubs its climate neutral products Cool Carpet, which becomes a huge marketing success, contributing incremental sales and lifting the company's image far more than advertising would have. Sure enough, we see that waste can be food, as in nature. In nature, one organism's waste is another's food. A carpet factory manager in Southern California, where there's lots of sunshine, muses over the possibility of using photovoltaics to produce some of the factory's electricity. He scouts around. He discovers that state assistance is available for just such projects. And then he asks his accountant to work out the justification. Yet even with state assistance, the project doesn't pencil, according to the accountant, who's looking hard at costs. But the manager doesn't give up. He asks his marketing and sales counterparts, can you sell solar-made carpet, something the world has never seen before? Without hesitation, they reply, bring it on. And today, 120 kilowatts at peak sunlight of photovoltaic factory-generated voltage is connected to the California grid, and it's producing electricity in such quantities that were the electrical current channeled into the tufting process of the factory, it would power the production of 1 million square yards a year of solar-made carpet, generating incremental sales which the accountant overlooked in his preoccupation with costs. Decisions made in the round, another term for interdisciplinary, including marketing and sales and customers, are better decisions. This new thinking is brought on by technical innovation of the new industrial revolution, the solar revolution, and solar-made becomes the forerunner of Cool Carpet. A product designer, frustrated with the lack of progress in implementing sustainable design, pleads, let's do something, anything. So a designer redesigns a typical product to have 4% less of its most expensive and energy-intensive component, in this case DuPont nylon. The redesigned product performs well in all the usual tests, so for the moment this is considered to be the something that the designer was pleading for. But an engineer, thinking new kinds of thoughts, wonders about the effect upstream of this kind of design modification if it were made across the factory's entire product line. So he asked DuPont a question that DuPont has never, ever been asked before. How much energy did DuPont expend from wellhead to my receiving dock in making and delivering that bit of nylon? This is now commonly referred to as embodied or embedded energy. The DuPont response is applied by the inquiring engineer theoretically across the hypothetically redesigned product line, and to his amazement and everyone else's, on an annualized basis, this turns out to be enough energy not used by DuPont call it mega energy, to run the engineer's entire factory for 2 years. Today, the average product in this factory contains 16% less nylon, to Earth's great benefit, because the offset is equivalent to 10 years of nega energy. To those who are doing the math, it's 10 years, not 8, for in the meantime, the factory has also reduced its energy usage. The approach is now referred to as dematerialization through conscious design. It's new thinking that considers upstream effects, whole system optimization of another type with expanded boundaries of consideration. The new thinking reminds us that each of our companies or organizations, yours included, is its entire supply chain. No one stands alone. A team of engineers and production personnel and product designers collaborate to find another way to create patterned carpet. The conventional way employed for years by the factory and its chief competitors is to print patterns on a plain colored carpet base. Printing is water intensive and energy intensive, therefore greenhouse gas intensive, requiring an aqueous dye application, steaming to fix the dye, washing to remove the excess unfixed dye, and drying to remove the wash water. Used wash water also requires chemical treatment before release into the waterways. But new thinking suggests that the tufting machine that forms the pile face of the carpet in the first place has untapped potential to precisely place tufts of yarn of selected colors to form quite intricate patterns. So the bold decision is made to burn the bridges and abandon wet printing altogether, to scrap the existing stranded investment. Left with only one means of creating patterns which the marketplace demands, development efforts result in entirely new families of patented inventions, giving the factory a proprietary edge rather than a handicap in its marketplace. One of those patented inventions arises from the outrageous assignment by the head of design to his design team to go into the forest and see how nature would design a floor covering. And don't come back with leaf designs, he says. That's not what I mean. Come back with nature's design principles. The head of design has read Biomimicry by Janine Benyus. Biomimicry, nature as teacher, nature as inspiration, nature as mentor and measure. So the design team spends a day studying the forest floor and the stream beds, and they come to realize there's total diversity, even chaos here. No two things are alike. No two sticks, no two stones, no two leaves, no two limbs, no two anything. Yet there's a very pleasant orderliness in this chaos. So the designers go back to the design studio and design a carpet tile such that the face designs of no two tiles are identical. All are similar, but every one is different from every other one. Now, how contrary is this to the prevailing industrial paradigm that every mass-produced item must be the cookie-cutter same, Six Sigma uniformity? This new product is introduced to the market with the name entropy, suggesting disorder. And in a year and a half, it moves to the top of the bestseller list faster than any other product ever has. The advantages of breaking the old paradigm, this insistence on perfection and sameness, are surprisingly numerous. There's almost no waste, no off quality in production. Inspectors cannot find defects among the deliberate imperfection of no two tiles alike. The installer can install tiles very quickly without having to take the traditional care to get the pile nap all running uniformly. The less uniform the installation, the better. So he can just take tiles out of the box the way they come and lay them randomly. And there's almost no scrap in installation. Even piece tiles can find a place in the installation. And then the user can replace an individual damaged tile without creating the sore thumb effect of a new tile placed among the old that so typically comes with precision uniformity. Furthermore, there are no longer issues of dye lots. Dye lots merge indistinguishably. And this obviates the need for shelf stock, those extra tiles of the original dye lot on the shelf waiting to be used, solving an inventory problem. And the user can now even rotate the carpet tiles on the floor to equalize wear the way we rotate tires on our cars and make selective replacement of damaged tiles to extend the life of the entire installation. All of this is good for the environment through resource efficiency, using stuff more efficiently by design, biomimetic design. And yet, with even all of these unexpected benefits, one wonders, is there still more to explain the success of entropy? Well, perhaps there is. A speak on the environmental speaking circuit begins every speech by having her audience close their eyes and picture that ideal place of peace and repose and tranquility, serenity, creativity, comfort, security, that perfect comfort zone. We might try it here. Humor me. Everybody, close your eyes. And in your mind's eye, picture your ideal place of peace and repose and tranquility, and serenity, creativity, comfort. Your perfect comfort zone. Have you got it? Now raise your hand high if you're somewhere outdoors. Look around. Look around. It is just amazing the way we humans seem to gravitate to nature for that ideal comfort zone. And somehow I believe entropy brings outdoors indoors in a subliminal way, and that is its real appeal. The quality has a name, biophilia, coined by the great Harvard biologist Ed Wilson. There's enormous power in biomimicry and in biophilia. And this is very new thinking. Nature, the inspiration, is anything but uniformly perfect, yet she is very effective. A similar team, also inspired by biomimicry and thinking out of the box, asked, how does a gecko cling upside down to the ceiling? The question arises in a session to figure out how to completely eliminate glue from the installation of carpet tiles. Even free-lay carpet tiles need that 25-foot by 25-foot grid of anchored tiles stuck to the floor to create the repeating grid or picture frames of anchored tiles within which the self-laid tiles are installed without glue. But this session is about how to get rid of glue altogether, to burn that bridge, to dematerialize the installation process. And though the answer does not utilize van der Waals forces, as the gecko does, the answer is nevertheless completely revolutionary. A 2.5 inch by 2.5 inch releasable adhesive tape is applied sticky side up to the underneath side at each conjunction of 4 tile corners. The effect is to connect all the tiles into the installation laterally and then let gravity hold the room full of carpet tiles snug to the floor and in place like wall-to-wall carpet. Sticky side up, not down, and only 6 1/4 square inches at that, less than 2% of each tile's underneath surface. The new installation technique, called tactiles, provides the market with the world's first glue-free carpet tiles and becomes another successful proprietary differentiator for the company and its products. Glue is a petro-derived, devilish source of volatile organic compounds, VOCs, and can contribute significantly to poor indoor air quality, but not so anymore for this company's customers, thanks to new thinking, upside-down thinking, geckos, and carpet tiles. Who would have imagined? 7 examples. Real examples of industrial sustainability in action leading to new thinking and previously unimagined innovations. As I review them, find the analogs in your own setting. Whole system optimization, big, short, straight pipes and small motors, not the other way around. Waste as food, converted to a revenue stream, an energy source, and a greenhouse gas offset rather than continuing as a pollutant. A climate-neutral factory and cool carpet, win, 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 and an environmental injustice removed, another win. In the round, interdisciplinary investment decisions justified not on the basis of cost, ushering in a new industrial revolution supported by enlightened market demand. Dematerialization through conscious design and upstream thinking, the leverage may be up there. No one stands alone. Burn the bridges, abandoning high-impact technologies for low-impact, and out of necessity creating new inventions and a better way. Biomimicry, how would nature do this? Biophilia, subliminal appeal to our limbic impulses designed into products to achieve higher levels of customer psychological well-being and satisfaction. Think upside down. As physicist and energy expert Amory Levin says, the best way to have good new ideas is just stop having the bad old ideas. Believe me, I could go on and on with examples of new thinking. 13 years of this kind of new thinking and innovation combined with a determination to abandon the comfort of the status quo can produce unimagined results. Yet it does not come naturally, only through extraordinary commitment. The status quo is an opiate, a powerful opiate. Breaking with we've always done it this way is hard. Yet I know an industrial company that did make the break in the total, absolute, wholehearted pursuit of sustainability, and in the process is transforming itself daily. I know firsthand this is true, because that company is my company, Interface. This is sustainability in action, new thinking, finding previously unimagined, innovative, new and better ways. What has it cost? It hasn't. Our costs are down, not up. The business case is crystal clear. Costs are down. Waste elimination alone has contributed $372 million of savings over the last 13 years. Our products are the best they've ever been. Some 82 products are now designed to the biomimicry principle, no two tiles alike, and represent more than 40% of carpet tile sales. Our people are galvanized around this shared higher purpose of eliminating Interface's footprint altogether by 2020. We call it Mission Zero. This means zero waste, zero harmful emissions, 100% renewable energy, 100% renewable materials, closing the loop on material flows, and climate-neutral transportation of people and products. It also means an entire supply chain, suppliers, customers, communities, ourselves, forming an ecosystem, to borrow a term from nature, and moving together up this high mountain named Mount Sustainability, with trust and cooperation replacing confrontation. That's a concept. Trust in the commercial world. And to complete the business case, the goodwill of the marketplace has been astonishing. No amount of advertising, no slick marketing initiative could have bought it. And believe me, we do not take it for granted either. Goodwill is earned every day by doing, not by talking. How far up the mountain have we come? Here are some metrics. Net greenhouse gas reductions, 82% in absolute tonnage versus the 1996 baseline. And if we counted renewable energy credits, the RECs, which we do not, we would be at minus 110%. But we don't count the RECs until the double accounting issues are resolved. So 82% in absolute tonnage. Water usage down 75%. Fossil fuel derived energy down 60% per unit of production. With oil at $135 a barrel, that even plays well at Wall Street. Renewable energy is now 88% of total electricity. 9 of 11 factories run completely on renewable electricity. The goal is for all factories to do so. Renewable energy is 27% of total energy. We use more energy than just electricity. The goal is 100% renewable. Smokestack. Who counts smokestacks? We do. half have been closed, obviated by process changes. Effluent pipes, 81% abandoned, obviated by process changes. Travel, greenhouse gases from 175 million airline passenger miles, offset with the planting of some 87,000 trees, though admittedly there's a time lag while the trees grow. The company automobile fleet emissions completely offset at a cost of 2.5 cents a gallon. Renewable materials are now more than 25% of total and increasing rapidly. The goal is 100%. We're now in the market for used carpet, any manufacturer's carpet. And of course, we would like to replace it with ours. Scrap to the landfill is down 2/3. The goal is 0 scrap to the landfill. Total waste is down 52% in 13 years, contributing to $372 million in savings. Re-entry, our process for capturing our products at the end of their first life and diverting them from landfills and incinerators through closed-loop recycling, 133 million pounds captured over the years. Precious organic molecules given life after life. Altogether, we're about halfway to our objective, Mission Zero. Half the time from start to finish, 1994 to 2020, has elapsed. We're on schedule. Nearly 14 years ago, when we set this goal, people thought it was impossible, that I had gone round the bend. A competitor looked me in the eye and called me a dreamer. Yet, as Amy Levin says, if it exists, it must be possible. I say the entire industrial system must travel this road, but is it possible for the entire industrial system? Why not? If we can do it, anybody can. What is needed beside the willpower? Strong signals from the market, from customers everywhere. That includes you, to your entire supply chain, that say this is how we make our purchase decisions from now on, and thousands of educated change agents to respond to those signals. Which brings us to you and your deeper role in creating change, which seems to be inordinately difficult generally for your collective institution, even in critical times like these, with global climate change coming at us like a freight train. So what about the universities and the roles that they must play? Will they be part of the problem or part of the solution? Where will they stand in the years ahead with respect to the gathering threat of climate disruption and biological decline? Will they teach new thinking or old thinking? Will they train change agents or caretakers of a system of destruction? Technology, as taught at the university level, for sure must become part of the solution instead of continuing to be a major part of the problem. So will our mechanical engineers continue to learn about petroleum-dependent internal combustion engines? Or will they study fuel cells? Will our electrical engineers continue to learn about coal-powered central generating power stations? Or will they study wind and photovoltaics and hydrogen and biomass distributed generation? Will our ceramics engineers still learn the traditional 2,000-degree heat beat treat methods? Or will they study the abalone's natural nanotechnological method, as it makes better ceramics, that mother of pearl nacre, than any man-made ceramic, and does it out of readily abundant minerals in seawater at 40 degrees Fahrenheit? Will our textile engineers still learn to make Kevlar with boiling sulfuric acid, or study the spider, as it makes 5 times stronger, more resilient textile fibers out of bugs at body temperature? Will our chemistry students proudly learn to make the next deadly PCB or chlorofluorocarbon? Or will they learn green enzymatic chemistry in water? And not just technologies. Will our economic students continue to be taught that the externalities, the cost to society and the environment, don't count in the economic system, and that perverse subsidies are somehow good and deserved? Or will they learn about true full cost accounting that would put the cost of a barrel of oil at fully $300 a barrel if the cost of the wars in the Middle East were included, or if the cost of global warming to future generations were charged today to the burning of that oil? Will our ag students continue to learn petroleum-intensive, greenhouse gas-intensive industrial cultivation of annual food crops? Or will they study Wes Jackson's methods at the Land Institute for producing organic, self-rotating, pesticide-free, fertilizer-free, perennial crops, true sustainable agriculture? Will our designers be taught that good design is when there's nothing else to add, or good design is when there's nothing else to remove, as when Michelangelo freed the David's perfect hand from the marble that imprisoned it? Will our law students be taught that compliance and defending their clients' bad behavior is their highest calling? Or will they be urged to think beyond compliance and insist that their clients come with them and embrace ethical behavior? Will accounting students learn simply to keep score as the system collapses around them? Or will they devise ways to tell business how destructive they are and sound the alarm right up to the Securities and Exchange Commission? And will our business students, what will they be taught? That business exists to make a profit? Or that business makes a profit to exist and must surely exist for some higher purpose than that? Will they be taught that earth is fair game to do with as they please as they seek their fortunes? Or will they be reminded of the lesson in one of the wisest of all the allegorical fables they read as children, Jack and the Beanstalk, that nature is the goose that lays all the golden eggs, and to squeeze her too hard is to commit one's own self and humankind to a poverty too sad to contemplate? And finally, will our teachers continue to be taught the present outmoded, destructive system so they can pass it on and perpetuate it for another generation or two or three? Or will our universities wake up to their responsibility to challenge the obsolete status quo in their curricula? Will curricula be locked in the past and more of the destructive same, or focused on a sustainable future? This year's fourth graders are the graduating college seniors of 2020, the year Interface is targeting for zero footprint total sustainability. What must those graduates have learned if they hope to work for Interface or other companies, and there are many aiming at this same high target? What must they have learned if they hope to be part of creating a sustainable society into the indefinite future? Certainly not internal combustion engines and all the rest of the first industrial revolution learning. A new industrial revolution is underway. It's Rachel Carson's revolution. There are new and noble fortunes to be made doing well by doing good. The call is clear. Come aboard now. The time for pondering has passed. Thank you.